Hello students, in this video we're going to discuss about ICSE Class 7 Chapter 5 Language of Chemistry. Before we discuss deeply about language of chemistry, you need to know what is the meaning of this chapter Language of Chemistry. Firstly, you have to know what is language. Language is the medium of communication through which we communicate each other. In chemistry, we use special symbols, formula, some terms, and chemical equation for communication, which explore any information about any concept in chemistry. So let's start this video with the first concept, chemical change. A chemical change happens when one chemical substance is transformed into one or more different substances. One or more chemical species which involve in the change is transformed into one or more different substances. Always you'll get different substances at the end of the chemical change. Then what is chemical reaction? A chemical reaction is a change where different substances react and their chemical composition changes to form a new substance as a product. One or more chemical species involved in the change, they undergo changes in their chemical composition to form a new substance. Chemical species which involve in the change is known as reactants. The new substance which is formed at the end of the change is known as products. Example, this is the formation of water molecule. Hydrogen oxygen react. They form water molecule. Hydrogen, oxygen which involve in this chemical reaction is known as reactants. Water molecule which is formed as a result of this chemical reaction is known as product. Always you'll find reactants at the left hand side of this arrow mark and products at the right hand side. This is the general representation of the chemical reaction. Reactants at the left hand side, products at the right hand side. Formation of rust is another example of chemical change. When iron comes in contact with immediate environment, it reacts with oxygen and water which is present in the moisture, forms oxides of iron, which is a brown color precipitate deposit over the object. This is also known as rust. So, iron, oxygen, water, which involves in this chemical reaction is known as reactants. A new substance formed at the end of the change, that is oxides of iron, is known as product. Rust is a new substance formed at the end of the change. This is known as product. Then what is chemical equation? A chemical equation is the symbolic representation of a chemical reaction with the help of chemical formula of the reactants and the products which is involved in the reaction. The reactions can be represented by either a word equation or by a chemical equation using symbols and formula. This is the word equation of formation of magnesium oxide. Magnesium burns in the presence of oxygen, forms magnesium oxide. Magnesium, oxygen, which involve in this chemical reaction is known as reactants. Magnesium oxide, which is formed at the end of this change, is known as product. Magnesium oxide is a new substance formed at the end of this change. It is known as product. This is the chemical equation of formation of magnesium oxide. This is the symbol of magnesium. This is the symbol of oxygen. This is the formula of magnesium oxide. This is the chemical equation of formation of magnesium oxide. This is the word equation and the chemical equation of formation of ammonia. Nitrogen reacts with hydrogen, forms ammonia. This is the symbol of nitrogen. This is the symbol of hydrogen. This is the formula of ammonia. So nitrogen, hydrogen, which is involved in this chemical reaction, is known as reactants. Ammonia is a product. In a chemical reaction, it may have one reactant or two or more than two reactants. One reactant may involve in a chemical reaction, form two or three products. Two reactant may involve in a chemical reaction, form one product, or two reactant may involve form two products. Two reactants may involve in a chemical reaction, form three or more product. Examples. This is an example for one reactant and two or three products. So this is a lead tetroxide, forms lead oxide and oxygen. So lead tetroxide is a reactant, form lead oxide and oxygen, two products. So this is an example for chemical reaction which involve one reactant and form two products. Next, two reactant and one product. Copper reacts with oxygen, form copper oxide. Formation of copper oxide is an example for chemical reactions which involve two reactant, form one product. Next, two reactant and two products. Formation of aluminium trichloride and barium sulfate. When barium chloride, aluminium sulfate reacts, they form aluminium trichloride and barium sulfate. In this chemical reaction, two reactants involved in this chemical reaction formed two products. So this is an example for two reactant and two products. Next, two reactant and three or more products. Phosphorus reacts with nitric acid, form nitrogen dioxide, water and phosphoric acid. Next, we are going to discuss about types of chemical reaction. There are 5 different types of chemical reaction: direct combination, decomposition, displacement, double displacement, neutralization. First, we discuss about direct combination or synthesis reaction. A reaction in which two or more substances combine together to form a single substance is called combination reaction or synthesis reaction. This is the general representation of a combination reaction. A and B are reactants. AB is a product. A and B, both are reactants, combined to form a new substance AB. So this is an example for synthesis reaction. Substance, one or more substance combine to form a new substance, a single new substance. Next, this is the formation of water molecule. Hydrogen, oxygen combine to form water molecule. So hydrogen, oxygen, two reactants combine to form a new substance, water molecule. So this is an example for direct combination reaction, and this is also known as synthesis reaction. Next, chemical decomposition or analysis reaction. So the chemical reaction in which the compound splits into two or more simpler substances is called decomposition reaction. In a decomposition reaction, compound is broken into smaller species. Decomposition is the breaking up of the compound either into elements or compounds. So AB is a compound split into two simpler chemical species C and D, may form two products or more than two products. Example, this is a decomposition of water molecule. Water molecule split into hydrogen and oxygen. Here the compound split into two simpler species, hydrogen and oxygen. Next, we're going to discuss about single displacement reaction. Single displacement reaction is also known as substitution reaction. A substitution or single displacement reaction is characterized by one element being displaced from a compound by another element. This is a general representation of a single displacement chemical reaction. I would like you to imagine A is an element, BC is a compound. Compound BC has two elements B and C, but this BC is a compound. A displaces B from its compound. BC occupies B's place so that it forms a new compound AC. So this is known as single displacement reaction. In single displacement reaction, one element displaces other element from its compound. Usually, more active metal displaces less active metal from the compound. This is a reaction between copper sulfate and zinc. This is an example of single displacement reaction. Zinc, it's an element, displaces another element from the compound. Zinc displaces copper from its compound, occupies copper's place so that it forms new compound zinc sulfate. Copper displaced from its compound, displaced by zinc. So this is a displacement reaction. As one element displaces another element from its compound, this is known as single displacement reaction. In single displacement reaction, more active metal displaces less active metal. Zinc is more active metal than copper, so zinc displaces copper from its compound. But you won't get reactions between zinc sulfate and copper. Why? Copper is less active than zinc. So copper will not displace zinc from its compound. So you'll get no reaction. Single displacement or substitution reaction is characterized by one element being displaced from a compound by another element. More active metal displaces less active metal. Zinc displaces copper from its compound, forms zinc sulfate and copper. As zinc is more active than copper, zinc can displace copper from its compound. But as copper is less active than zinc, copper will not displace zinc from its compound. Next, double displacement reaction. In a double displacement reaction, two compounds exchange their radicals in order to form different compounds. This is a general representation of double displacement reaction. A, B, C, D are reactants. A, B and C, D are compounds. These compounds exchange their radicals, form two different compounds A, D and CB. You know that compound has two parts, cations and anions. Okay, so these compounds exchange their anions and cations, that is radicals. They form two different compounds. This is known as double displacement reaction. An example of a double displacement reaction occurs between sodium chloride and silver nitrate to form sodium nitrate and silver chloride. So sodium chloride, this is a sodium chloride formula, sodium chloride. This is silver nitrate. Two reactants involved in this chemical reaction, NaCl, silver nitrate, both are compounds. These compounds is going to exchange their radicals to form two different compounds. NaCl, Na is a basic radical, cation. Cl is an anion, which is an acidic radical. In silver nitrate, Ag is a basic radical, nitrate is a acidic radical. Ag is cation, nitrate is an anion. So these compounds is going to exchange their radicals NaNO3 AgCl. In a double displacement reaction, two compounds exchange their radicals in order to form two different compounds. Next, neutralization. The reaction between an acid and a base that forms salt and water only is referred to as a reaction of neutralization. So, in neutralization reaction, you'll find acid and base as a reactants, salt and water as a product. This is the formation of NaCl sodium chloride. This chemical reaction is an example for neutralization. Why? Because we'll find sodium hydroxide base and HCl acid in this reaction. So this reaction is between base and acid. Sodium hydroxide is a base. Hydrochloric acid, HCl, is an acid. So when acid and base reacts, it forms salt and water. When sodium hydroxide HCl react, they form sodium chloride and water. Sodium chloride is a salt. So neutralization is a reaction between acid and base that forms salt and water only as a product. Types of reaction, definition, equations. This is a general representation of this reaction. Synthesis. Two or more elements or compounds combine to make a more complex substance. So in the synthesis or combination reactions, two or more elements or compounds combine, they form more complex new substance. In decomposition, compounds break into simpler substance. Compound AB split into A and B. So this is a general representation of decomposition reaction. In decomposition reaction, compounds break down into simpler substance. But whereas in synthesis, two or more elements or compounds combine to make a more complex substance. Elements or compounds combine to form a new compound. Single displacement reaction occurs when one element replaces another one in a compound. In this general representation, C is an element. It displaces B from its compound AB, occupies B's position, forms a new compound AC. So this element C displaces another element from its compound. So this is a this replacement reaction or displacement reaction. Next, double replacement is also known as double displacement. Occurs when different atoms in two different compounds trade places, exchange their radicals. A, B, C, D. So these are two compounds, A, B, C, D forms AC and BD. They exchange a radical, they form two different compounds in double displacement reaction. So therefore, there are four main types of chemical reaction: synthesis, decomposition, single replacement, double replacement. In synthesis, two or more elements or compounds combine to form a new substance, a new compound. In decomposition, compound split into two simpler chemical species. In single replacement, one element displaces another element from its compound. So this is known as single replacement or single displacement reaction. In double displacement or double replacement reactions, you will have two compounds. See here A, B, C, D. They exchange their radicals. They mutually exchange their radical, form two different compounds A, C and B, D. Next, signs of chemical change. What clues tell you a chemical reaction has occurred? Yes, release of bubbles, change of color, release of heat and light, production of odor, production of loud sounds. These are signs of chemical change. It indicates as a chemical reaction has taken place. There are 5 signs of chemical reaction which indicates chemical reaction has taken place. They are color change, temperature change, formation of gas, appearance of precipitate, emission of light. Next, we are going to discuss about some characteristic change of chemical reaction. This characteristic change of chemical reactions indicate as the chemical reaction has taken place. Change in color of the substance, change in state of the reactants, change in smell, evolution of gas, formation of precipitate, evolution or absorption of heat. First, change in color of the substance. For example, during the process of rusting, we have discussed already about the rusting process. We'll get a reddish brown powdery substance at the end of this rusting process. When the iron objects comes in contact with the immediate environment, it reacts with the oxygen and water present in the moisture, form oxides of iron, which is nothing but rust. It's a brown color precipitate deposit over the iron object. So this chemical reactions involve in the color change in color of the substance. And this color change of the substance indicates as chemical reaction has taken place. Next, we are going to discuss about change in state of the reactant. This chemical equation for formation of ammonium chloride. This is the formula of ammonium chloride, NH4Cl, which is in a solid form. Ammonia hydrogen chloride react to form ammonium chloride. Ammonia, hydrogen chloride, both are reactants. Ammonium chloride is a product in this chemical reaction. Ammonia, this is the formula of ammonia. This is the formula of hydrogen chloride. Both the reactants are in gaseous form, but when you check the state of the product, you'll find it is a solid form. It's a solid form. So this chemical reaction, formation of ammonium chloride, involve in change in state of the reactants. Change in smell. Some chemical reactions involve change in smell of the substance. Change in odor. Chemical reactions may give off a smell or new odor. Example, food rotting, rotten eggs are some example. Next, endothermic reactions. That is, chemical reactions which involve absorption of heat energy during the process. Reactants absorb heat energy to form products. This type of reaction is known as endothermic reactions. Example of endothermic reactions. An endothermic reaction is any chemical reactions that absorb heat from its environment. Example, frying an egg, evaporation, photosynthesis. These processes absorb the heat energy from its environment. During frying, during cooking process, during evaporation, during photosynthesis, substance absorb heat energy from the environment in order to produce the product. Next, exothermic reaction. During exothermic reaction, substance react, they form products. Along with the products, they liberate some heat energy. In endothermic process, reactants absorb heat energy, form products. But in exothermic reaction, during the chemical process, the heat energy will be liberated from the system. Heat is evolved during the process. That is exothermic reaction. Next, evolution of gas. Chemical reactions which involve in the evolution of gas. This is an example of the chemical reactions which evolve the gas. Sodium carbonate, when it reacts with hydrochloric acid, it forms sodium chloride, water and carbon dioxide. Carbon dioxide is a gas. So this chemical reactions, that is formation of NaCl by sodium carbonate and HCl, is also involve evolution of gas. So endothermic reactions absorbs the heat energy from its environment. Exothermic reactions liberate heat energy. So in chemical reactions, you'll find reactants at the left hand side of this arrow mark, products at the right hand side. So this is the formation of water. Hydrogen, oxygen, both are reactants. Water is the product. This equation is an example for there is a combination reaction. Hydrogen, oxygen combine, they form new product, water. So this chemical reaction is also an example of combination reaction. Next, sodium, when it reacts with a chlorine, forms sodium chloride. This is the formula of a sodium chloride compound. This is also an example of combination reaction. Another example of combination reaction, iron reacts with a sulfur, forms iron 2 sulfide. This is the symbol of iron. This is the symbol of sulfur. This is the formula of iron 2 sulfide. Iron and sulfur are reactants. Iron 2 sulfide is a product. Next, this is the formation of magnesium oxide. This is the formula of magnesium oxide. When magnesium burns in the presence of oxygen, forms magnesium oxide. This is the symbol of magnesium and this is the symbol of oxygen. Magnesium, oxygen are reactants. Magnesium oxide is a product in this chemical reaction. When silver nitrate reacts with sodium chloride, forms silver chloride and sodium nitrate. This chemical reaction is an example for double displacement reaction. This chemical reaction has two reactants. Two reactants involved in this chemical reaction forms two products. This is the example for decomposition reaction. Water molecules split into two simpler species, hydrogen and oxygen. These are products and this is a reactant. Reactants, the chemicals existing before the reaction. Products, the chemical produced by the reaction. Two molecules of water split into two molecules of hydrogen and one molecule of oxygen. This arrow means produces, symbolizes a reaction taking place. Water molecule produces hydrogen and oxygen. This arrow means produces. This coefficient, the big number in front, shows how many of each molecule is involved in the reaction. two molecules of hydrogen, two molecules of oxygen. This is common for the constituent elements. This is formation of carbon dioxide. This chemical reaction is for formation of carbon dioxide. This is the formula of carbon dioxide. This is the symbol of carbon and this is the symbol of oxygen. Carbon, oxygen are reactants. Carbon dioxide is a product. And this one is a formation of hydrochloric acid. Hydrogen, chlorine combine to form hydrochloric acid. Thank you so much, students. Hope you have enjoyed this video. If you like this video, click the like button. Subscribe my channel for more videos. Share to your friends. Keep returning to my channel.